Hi, and welcome back. Last time we talked about the squares trick with the diagonal and squaring the number in the diagonal and the addition of the two numbers next to it. Today we're going to be talking about factorials, combinations, and how you can find them in the Pascal Triangle. For this first part, we're going to be talking about what is a factorial and what is a combination. Because to find combinations in the Pascal Triangle, you should know what combinations are. So we say that n factorial is equal to n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1. Essentially, you can say that n factorial is taking n and multiplying it with all the numbers down to 1. And we do have a special notation for factorial, and it's just an exclamation mark. So n exclamation mark, or n factorial, is still equal to that. And just remember that when I do put an exclamation mark, I don't mean n, I mean n factorial. So if you need an example of a possible factorial, 4 factorial is equal to 4 times 3 times 2 times 1, which is just equal to 24. And we can just do a couple. Times 2 times 1 is equal to 6. 2 factorial is just equal to 2 times 1 goes to 2. 1 factorial is obviously just 1. And if you want to just do one number which is higher, 5 times 4 times 3 times 2 times 1 equals 120. A useful thing to note is that, and it might seem really obvious, but if you do 5 factorial equal to 5 times 4 times 3 times 2 times 1, it's actually just equal to 5 times 4 factorial. Because you can take this, you can just convert it to 4 factorial. So if you wanted to use variables, you can just say n factorial is n times n minus 1 factorial. And this is used a lot, and this is also going to be used in combinations. An example of how you might use this in a problem goes like this. If you have 3 marbles, I have a yellow marble, I have a blue marble, and I have a red marble. And I want to know in how many ways I can draw these marbles out of a bag. And I do put the marble back in the bag afterwards. So what I do is that I'm just going to say that this is how I can draw it. I can either draw the yellow marble first, I can draw the orange marble first, or I can draw the red marble first. If I draw the yellow marble first, I have 2 choices for what I can draw next. I can either draw the orange marble, or I can draw the red marble. If I drew the orange one, I have 2 choices. I can either choose a yellow one, or I can choose the red one. And I also have 2 choices for the red marble. I can, as you probably predict, pick a yellow one or an orange one. If I pick the orange one, I only have one option left, which is the red one. If I have picked the red marble, I only have one left, which is the orange marble. If I pick the yellow one, I have to pick the red one. If I picked the red one, I'd have to pick the yellow one. If I pick the yellow one, then I'd have to pick the orange one. And if I pick the orange one, I'd have to pick the yellow one. So as you see, we can count how many possibilities we have. We have 1 here. We have 2 here. We have 3 here. 4 here. We have 5 here. And we have 6 here. So there's 6 possible ways I can rearrange this. But if I had more marbles, like if I had 10 marbles, that'd be a little hard to count with this diagram. So let's think about a little more exactly what we did here to see whether we can find a simpler way to solve this in the future with bigger numbers. Well, we have 3 marbles we can choose for the first one. Then, no matter which marble we pick, then we have 2 other marbles that we can pick. And no matter which marble we pick, after that, we only have 1 marble for the last one. And this is equal to 3 factorial, which is 6. So now that we understand what a factorial is, we'll talk about what choosing is in the next episode.